Hi and welcome to the latest Quickfire video, where we talk to leaders in the Internet of Things. My name's Jeremy Cowan, publisher of IoT Now, and today I am delighted to welcome Michael Basca, Senior Director for Industrial and Consumers at Micron. Michael, welcome.
Happy to be here. Thanks so much, Jeremy.
Well, for anyone not familiar with this sector, Micron are specialists in this innovative memory and storage solutions sector. Based in Boise, Idaho, USA, Micron employs roughly 40,000 people in no less than 17 countries, working with trusted brands to deliver memory and storage systems for a wide range of applications. Michael, edge computing is about bringing compute closer to the source of data. What is the mindset shift around considerations of memory and storage between a cloud-based approach and an edge-based approach?
Yeah, such an exciting time. Obviously, the cloud has already brought so much innovation to so many industries, to the factories and retail, small businesses and large businesses. And now there's an evolution that's happening at the edge. It's going to be the next step forward in bringing additional capabilities and business intelligence to the edge. If we look at the edge itself, we have a variety of different sensors, video, IoT devices. And in the past, right, they've had somewhat limited capability, but moving forward, we're seeing much more capability that we'll go into some detail, the benefits that can have. And so really the edge and the cloud we see as complementary. So you're still going to have the very strong backbone of the cloud that's there for massive storage and massive compute capability, but the edge is increasingly becoming a place of intelligence for real-time decision-making and analytics that can help drive that productivity locally.
Well, expanding on that a little bit, with the onset of 5G at the edge, how do you see Micron's role in supporting these applications?
Yeah, so 5G in particular, we're excited for multiple reasons. In industrial settings, which is a lot of where this edge innovation is going to happen, we see a major advantage with the low latency that 5G is going to bring to these devices that exist at the edge. And so, whereas in the past, a lot of that computation needed to happen centrally in the data center, as edge devices now have more compute capability and this low latency, it opens itself up to that real-time decision-making at the edge with central monitoring and central and remote control through the cloud to the edge. And so in these industrial use cases, we're really seeing, again, this is not necessarily room temperature applications. So you may have much more robust needs for the temperature capabilities of the device, the robustness to handle other environments, as well as the quality and reliability of the memory and other devices that are in this space, because it's harder to go out and service these. They're remote, they're in various different locations. And so we're seeing a whole new evolution of the memory that's going into these edge devices at the leading edge of our technology.
Could you give us an example just to help dive a little deeper into understanding how edge computing is changing and how we should now consider memory and storage?
Yeah, so let's talk about video surveillance, which is now really evolving into video security and analytics. So traditionally, many of us are familiar with, right, the old, very low-tech camera that would kind of sit, in the corner of whatever store or other locations that you might see it in. That was a very low memory content device. It was also a very low compute-capable device. But now with the cost-effective high resolution that can go into these cameras, as well as the compute power that can be located in them, also for relatively affordable prices, this opens up a whole new capability to transition this to now being an AI and ML inference device that will not just record, but will actually collect the metadata, image recognition. This can drive a whole new range of applications and business intelligence locally for the device. In terms of memory, what this means is it means higher storage content. So we're seeing adoption of micro SD cards and SSDs, again, with a tilt toward industrial requirements. So we're specifically seeing what we call our industrial temperature grade memory. And on the SSD side, we have SSDs that are specifically targeted for the reliability and the workloads required by industrial and automotive needs. On the compute side, the DRAM side, we're seeing similarly much higher density memory going into these devices. In some cases, DRAM modules, which used to be the land of laptops and servers and very high compute, but we're seeing that work its way into cameras, as well as some of our leading edge low power DRAM. So our LP4 and LP5 memory is capable of a lot of this inference compute power that can be done locally inside of those devices.
Just as an aside, would you say that these kind of security camera applications are the preserve of the SME or even enterprises, or is it something that is now reaching into the consumer sector?
Yeah, so we're seeing elements of both of those. We're seeing a lot of adoption in retail environments, in smart factories, smart cities, and campuses. There is consumer, and many of us are used to the device on the front door that hopefully will protect our packages. But most of where we're focused in our part of the business is in the industrial applications. And so in that space, in some cases, the enterprise will manage that themselves. And in some cases, they will farm that out to a video as a service type of device with that remote control, remote monitoring model, where again, in those cases with these devices located remotely, it's pretty expensive if something goes wrong to roll a truck out and the cost that's incurred to service that device. And so this is again where the quality, the reliability, you want that memory and the other components in there to be able to survive and thrive through the full lifetime of these devices.
Looking at the big picture here for a second, I mean, edge storage devices have been around for some time, but with advances in technology, the business case is obviously evolving. How are increased memory retention and the ability to move storage to the camera itself creating new solutions beyond what we've already described? Are there any other areas we should be aware of? And what should end users be looking for with regards to their storage infrastructure?
Yeah, so ultimately there's going to be integration if we think about a factory environment. So yes, we talked about the video security, but of course there's a whole variety of other sensors on the machine equipment in terms of servicing and throughput capabilities. And ultimately, all of these different IoT streams are going to have tremendous value by being integrated together into a cohesive decision. So there's absolutely value in getting the learning out of an individual camera or an array of cameras. But there's even more value as we go out into some of these enterprise and smart city environments. If we think about integrating that with traffic control sensors and with weather sensors. I mean, all of that intelligence is still yet to be, but that's the next frontier where the cloud, again, a lot of that integration will happen at the cloud. And this is where both the cloud and the edge are going to have tremendous value moving forward. These devices at the edge will do a lot of that computing, but that final integration and additional level of intelligence will happen in the cloud.
So will cloud-based video applications and products continue to take off, or are we heading for a more edge environment? And if so, in what form? What form will it take?
Yeah, so we're excited for both, right? At Micron, we absolutely have, one foot in each. We see tremendous value in both. And it's really going to be a question of where you're trying to store the data, and how much of a algorithm, where you want to run your algorithms and at what level. Again, if you want to run them locally to optimize that specific data stream, that's where the edge is going to drive a lot of that data. And then, of course, the very high compute power that you have in the cloud itself. And one thing that we haven't spoken about yet is obviously you have to transfer the data in between those from the edge to the cloud, and that's not a trivial matter. And that it has its own cost and throughput challenges where there can be times during the day where it's difficult to get that real-time data up to the cloud. And so that's where the complementary nature of these two, where we can rely a little bit more on this intelligence at the edge, but still have the cloud to be able to do that ultimate integration and high-end compute power, is going to deliver productivity gains to the retail environments, to the factory environments. I can't wait to get into a smart city where hopefully the traffic will move more smoothly and we'll all be a little bit happier.
It's going to make a big difference to all of us. Well, I'm afraid that is all we have time for. It just remains for me to say a big thank you to Michael Basca of Micron for bringing all of that to life so well. Thank you, Michael.
Thank you so much, Jeremy.
And thank you, ladies and gentlemen, for joining us around the world. Till the next time, bye for now.